All right, welcome back, Precalculus students, to our 5.1 lesson. In the first video, I went through all the trig identities that you need to know. And these are all the identities you need for 5.1 and 5.2. There will not be any more new identities you're learning. This is all just about applying those identities now. So since we're running long in the last video, I wanted to stop and break it up and start over with video lesson number 2 using the first two examples from your handout. Uh, these are both going to use identities to evaluate some trig functions, okay, or some trig values. All right, so these will all give you numeric answers. All right, the second set of problems are going to be involved simplifying expressions. That's a little different. But the first two examples are just using trig identities to evaluate um, these problems. So example 1, use identities to find sine theta and cosine theta if you know tangent theta is 5 and cosine theta is negative. Okay, now this problem may sound familiar. We did problem similar to this in unit 4, where we drew a triangle and labeled two of the sides and used Pythagorean theorem to find the third side, and then figure it out from there. So now we're going to approach the same problem, but a different method. They want us to use identities. So I need to see you using identities to solve these problems. You cannot solve them by drawing a triangle. You need to use identities. Okay. And for these kind of problems, you always want to start with one of the Pythagorean identities. So let me write that down. Start with a Pythagorean identity. Okay, because let's just review here, right? There's 3 Pythagorean identities, each of them using 2 trig functions. So if I know one trig function, I can solve for another one using the Pythagorean identity. If I know sine, I can solve for cosine, or vice versa. Cosine is solve for sine. Tangent and secant, cotangent, cosecant. So what do I know in this example here? Well, let's see. I know tangent theta is 5. That's what I'm given, right? I'm given tangent theta is 5. Well, there's only one Pythagorean identity using tangent, and that's this one. Tangent squared plus 1 is secant squared. So you always, with these kind of problems, you always want to start with a Pythagorean identity using whatever trig value you are given. So let me write that down. Tangent squared theta plus 1 equals secant squared theta. So now let me plug in what I know. I know tangent theta is 5. So 5 squared plus 1 equals and secant squared theta. And let me go back and write this now with the proper way. It's really secant theta quantity squared, because when I do my algebra, you want to see it that way. Okay, well 5 squared is 25 plus 1 is 26. So that means that secant theta quantity squared is 26. Well, I want to solve for secant theta. Now I really want to find cosine and sine, but I know that secant is the reciprocal of cosine. So once I find secant, I can just do the reciprocal to find cosine, okay? So I want to get secant by itself. Well, I want to get rid of the squared, so I'm going to square root both sides of the equation and say that secant theta is the square root of 26. But now be careful. Whenever you square both sides of the equation, remember we get two answers. It could be positive radical 26 or negative radical 26. So you might be saying, how do I know which one to use? Well, before we would look at what quadrant theta is in. Well, now we don't have to, we can just use this. What do we know? We know cosine is negative. Well, cosine and secant are reciprocals, right? So if cosine is negative, secant must also be negative. So secant theta is negative radical 26. And I'll even write why, because I know that cosine theta is negative. Okay. And now I'm almost done with the first part. I know secant, I want to find cosine. Well, as I said before, cosine is simply the reciprocal of secant. So just do the reciprocal. Negative 1 over radical 26, or if I rationalize the denominator, negative radical 26 over 26. Okay, so that is the first of the two answers it wants. There's your cosine, negative radical 26 over 26. All right, now I'm not done though. It wants to find sine. Okay, now you might say, could I use another Pythagorean identity? Sine squared plus cosine squared is 1. Yes, you could. That wouldn't be wrong. But there's an easier one you can use. All right. Now that I know cosine and I know tangent, I know tangent is sine over cosine. We're going to use this one a lot. Tangent and cotangent putting in terms of sine and cosine. So um, let me go to the side here now. I know that tangent theta is sine theta over cosine theta. Well, I want to get sine by itself. Solve for sine. Sine theta then is going to be cosine theta times tangent theta. All right. Well, I know both of those. Let's plug them in. Cosine theta is negative radical 26 over 26. Tangent theta is 5. Multiply those together. Sine theta is negative 5 radical 26 over 26. Okay. That is the second thing I wanted. Okay. So I found both the answers that it asked me to find. All right. Now you can verify doing the other method if you want. You can draw a triangle and label tangent is opposite over adjacent, label opposite 5, adjacent side is 1, and then use Pythagorean theorem to find the hypotenuse, and you'll see the hypotenuse is radical 26, same as we saw here. And then figure out the quadrant you're in and make it negative and go on and so on and so forth. So you can solve the way we did before. But for these problems, from when you do them from the book, I want to see you doing it like we did here. Practice using your trig identities. Okay, so the first couple homework problems I'm going to give you are going to be very, very similar to this example one. So look back at this, follow the same steps I did here. Okay, just always start with a Pythagorean identity, depending on which one you're given. Example 2. This one will be much shorter than the previous one. Use identities to find cosecant negative theta if you know that secant pi over 2 minus theta is 4. So I know this, I want to find this. Okay, well, let's start with what we know. You can only start with what you know. Obviously, don't know anything else yet. So start with that. Secant pi over 2 minus theta is 4. Okay. Anytime you see the pi over 2 minus theta, that automatically should tell you to use one of your cofunction identities. Right? Anytime you see that pi over 2 minus theta is one of your cofunction. Well, what does cofunction say? Secant pi over 2 minus theta is the same as the cosecant of theta. Remember, that's where that name co in cofunction comes from. Secant becomes cosecant. So this means that the cosecant of theta is also 4. Since these two are the equal, if this one equals 4, cosecant theta also is 4. All right, well, I'm almost there. I want to know cosecant negative theta. I have cosecant of theta. Well, anytime you see a negative theta, you think of or negative x, you think of the odd and even identities. All right, and I'm using cosecant. Cosecant is odd. The odd functions means if the input is negative, the output becomes negative. Well, so what does that mean here? I know cosecant theta, I want to find cosecant negative theta. Well, since this is odd, if the input changes sign, then the answer changes sign. So cosecant negative theta is negative 4. All right, and I'm done. That was my answer. Okay. Now, if this was an even function, going back here, if this was an even function, then when you made this negative, this one would stay positive. But since it's odd, then when this changes signs, this one also changes signs. Okay, so that's going to bring us to the first homework assignment I want to give you from the textbook is right here, page 403, 3 through 6, and 17 through 20. Okay, so let me just help you out, walk you through those in the book. Oh, it was 403. I'm sorry, not 406. Okay, so here we are. 3 and 4, as I said, is just like example 1. It gives you a trig function. Find two others using the identities. Okay. 5 and 6 are very similar to example 2, where you're going to use some combination of cofunction and odd or even identities to solve those. All right. And then finally, 17 through 20. All these simplify as either positive 1 or negative 1. Okay. And once again, you can see you're going to use either some combination of cofunction identities and the odd or even identities. When you see pi over 2 minus x, use cofunction. When you see negative x, use odd or even. So those are all going to simplify to either 1 or negative 1. All right. And make sure you show your work, of course. Don't just write down 1 or negative 1. You have to show the steps how you got the answer. That's what's important about these problems, is showing the steps where you got it. Okay. So I don't want to see just a answer 1 or negative 1, just like here. I don't want to see just a number answer. I need to see the steps where you got those. All right. So you can try those homework assignments first, and then I'm going to make another video lesson over the final few examples from 5.1.